Hello. This video will be about miscellaneous topics with radicals and exponents, which shows up throughout chapter 6, and I'm just trying to put the most important ideas all together. So we know when we take a square root, when I say the square root of x equals a, I'm really thinking to myself, what's the positive number where when I square it, I get x? So square root is thinking about squaring backwards. Which number do I need to square to get something else? So if we have another root, the nth root, so it could be third root, fourth root, etc., we're just raising some positive number to a different power to get something. Sometimes it can be negative, but we'll assume we're dealing only with positives. So as an example, the cube root of 64, right? The meaning of this is I'm thinking to myself, what is the number where if I raise it to the third power, I get 64? And you're not expected to have these memorized, but if you're being asked to do them without a calculator, there's this assumption that it won't be so bad. So we would look at this and think, all right, well, it needs to be an even number. 2 cubed is too small. How about 4 cubed? 4 times 4 times 4. Yeah, that's 64, so this is 4. Take a moment and try these other two. For the second one, we're basically asking ourselves, what's the number where if we raise it to the 5th power, we get 32? And hopefully you notice that that's 2. Here we're asking, what's the number where if we raise it to the 4th power, we get 81? And through a little bit of experimentation, presumably you notice that that's 3. And one thing to keep in mind, regardless of how hard you think the numbers are, when you have a power and a root that are at the same level, the same index, they will cancel each other out. So regardless of what z is, if I take z and raise it to the third power and then take the third root of that, the two operations, they're inverse operations. They cancel each other out and we're just left with z. Right? Similarly here, I don't know what 38 to the 7th power is, but I know the 7th root of that will be 38. And this cancellation works the other way. If I say, hey, what's the 7th root of 38, and then raise that to the 7th power, that's 38. Now, sometimes radicals are expressed using fractional exponents. The reason for that, I'm not quite going to get into. When you get to calculus, you will appreciate that there are certain formulas that you can apply anytime you're dealing with a power. And your ability to notice something like a radical as actually being a kind of power will make problems easier. So if we just have a fractional power that's 1 over something, that's a root. So here, for example, the 1/2 power of 9 just means, the second root of 9. And usually we don't write that 2. This is just the square root of 9, which of course is 3. What does 27 to the 1/3 power mean? It means the third root or cube root of 27. Maybe you don't have that memorized, but if you just take a few educated guesses, you should figure out it's 3. What is the 1/4 power of 10 to the 4th? That means the 4th root of 10,000. We're essentially asking, what's the number where when we raise it to the 4th power, we get 10,000? And hopefully you notice that's just 10. You don't have to have these memorized. Even I don't have them memorized. But if you're being asked to do them without a calculator, assume it's not that bad and just start experimenting with likely answers. Now we have some rules for combining exponents. And I'll write out what all of these mean. So if I have x squared times x to the 5th, that means x times x, that's what x squared is, times x to the 5th, x times x times x times x times x. And at the end of the day, this is just x times x times x times x times x times x times x. There are 7 of them. This is x to the 7th power. And so hopefully we notice what's driving this. Oops, that's a 7. Even though we're multiplying the expressions, we might notice we're adding the exponents. There's a general rule there. Here, when we're dividing, my numerator is x times 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 x. My denominator is x times x. And these two cancel with those two, and I have 6 of them left. Another rule seems to be emerging. Here's an 8, here's a 2. I'm dividing those expressions, but I'm really just subtracting the exponents. And this, well, squaring just means multiplying it by itself. So this is x to the third times x to the third. We'll write down what that actually means. We get x to the 6th. So over here, I am taking a power to a power. But it looks like that has something to do with multiplication. And here are the general rules. If I am multiplying together two expressions with the same base, base A, I can combine those into one expression where A is raised to the B plus C power. If I'm dividing two expressions with the same base, it's the B minus C power. If I have power to a power, my new power is the product, B times C, of those two original ones. And these rules work even when we have weird exponents that are fractions or negatives. These are general rules. So take a moment and try to simplify the following as best as you can. For this first one, it's just x to the 10th, because there's a multiplication rule. Here we could view this as y to the first over y to the third. By the subtraction rule, that's y to the negative 2. But if you were to cancel, you might notice that's actually the same as 1 over y squared. So this is a rule that probably you've seen before, and this is where it's coming from. So just a rule worth remembering here is that a negative exponent gives a reciprocal. Y to the negative 2 is the same thing as 1 over y to the 2. And then here we can do this in a couple of steps. In the numerator, I can use the rule that says when I am multiplying two expressions with the same base, I add the exponents. So 1.2 plus negative 1 is 0.2. And now over here, the division rule is that I can subtract those exponents. So this would be z to the negative 3.6, which you could write as 1 over z to the 3.6. That's the meaning of a negative power. Now, the meaning of a decimal power may be a little awkward. We're about to clarify that. So suppose we had to raise 8 to the 2/3 power. We already know what the 1/3 power is. The 1/3 power just means cube root. So the trick here is we could use one of these rules. I know that the number 2/3 is the number 1/3 times 2. So I could write it like this, 8 to the 1/3 to the second power. That's the same as 8 to the 2/3. But I know the 1/3 power means cube root. So this is the cube root of 8 raised to the second power. I know the cube root of 8 is 2. So my answer here is 2 squared, which is 4. Let's just focus on what's going on here for a general pattern. When we have a fractional exponent, the numerator represents the power. Right, let's write this down. For a fractional exponent, the numerator corresponds to the power. And the denominator corresponds to the root. So we have two operations in play. When we raise something to the 2/3 power, or the 3/4 power, or the 3/2 power, anything like that, some of it is giving us a power, some of it is giving us a root. And you can do them in either order. So just FYI, I wrote this as the cube root of 8 squared, but that's actually the same as the cube root of 8 squared. Sometimes one version will be easier than the other, but they will give you the same answer. So with that in mind, try these examples. Okay, so this means we have a third power, but a second root, a square root. So I have the square root of 9 and the third power of that. Square root of 9 is 3. 3 to the third is 3 times 3 times 3, which is 27. Here I have a fourth root and a third power. The fourth root of 16 is 2. 2 to the third is 8. For this example, right off the bat, we'll notice if it's negative, let's just write it as 1 over the corresponding positive power. So 7/6 power means I'm taking a sixth root of 1,000,000, and I'm raising that to the 7th power. And all of this is in the denominator of a fraction. This seems exotic, but if you pause for a moment, you will realize the sixth root of 1,000,000 is just 10. So this is 1 over 10 to the 7th, and 10 to the 7th is just a 1 with 7 zeros after it, which is 10 million. Right, so there is a little note here that I covered in my explanation, but it's not written down previously in the notes. A negative power just means 1 over the corresponding positive power. All right, that is it for this set of notes.